In this lecture, we will introduce Docker Compose. So what is Compose? Docker Compose allows you to define and run multi-container Docker applications. For example, if you have a Flask web application that requires a database, you can define the application and database as separate containers and then link them with Docker Compose. Scenarios like this are common, and not just with data storage. Think of a front-end JavaScript application with a Python back-end API, or an asynchronous application which makes use of a task queue, or a collection of microservices. In each of these scenarios, Compose would be beneficial and useful. So once you move past relatively simple examples with a single Docker file, Docker Compose becomes a smart choice, and this is why it's a very widely used tool in industry. How does Compose work? Well, here are some of the features that make Compose effective. First, multiple isolated environments on a single host, so this keeps all the benefits of Docker we discussed in the previous lecture. Preservation of volume data when containers are created. This means we can persist information as and when needed. Only recreate containers that have changed. This is critical because it means spinning up multiple containers is very fast. Variables and moving composition between environments. This allows for separation of code and configuration. What these features mean is that Compose works across multiple environments, from staging, testing, as well as CI workflows. Now don't worry if you don't understand all these details. The main thing is that you're able to make use of the tool. For those interested in digging into the details further, there are many links in the lecture notes. So why use Compose? If your Docker application includes more than one container, for example a web server and a database running in separate containers, then building, running and connecting the containers from separate Docker files is cumbersome and time-consuming. Docker Compose solves this problem by allowing you to define a YAML file to specify multi-container applications, and you can configure as many containers as you want, how they should be built and connected, and where data should be stored. And you can then run a single command to build, run and configure all of these containers. This combination makes Compose a very powerful tool. There are 3 steps to using Compose. First, define each service in a Docker file. Second, define the services and their relation to each other in a Docker Compose YAML file, and finally start the system. So let's focus on the second step here. Let's go through this example Docker Compose file you can see on the slide. To begin, we specify the version of Compose. At the time of this video creation, version 3 was the latest. We then list the services we will run, where each service will be a separate Docker container. In this case, you can see the first service here is called web, and we tell it to use a local Docker file located in the same directory as the Docker Compose YAML file with this build command. We map port 5000 of our container to our host machine, and we'll go into this in more detail in the setup lecture. We specify a volume for our web service where we can persist information such as logs, and we link the web service to another service which is called Redis. Now this is the second service defined in this Compose YAML file. Like the web service, an image is specified here, which means the image will be pulled from Docker Hub rather than built from a local Docker file. Now when we run Compose up, we will have 2 linked containers running. There will be the web container and the Redis container. Here are some key commands for working with Docker Compose, and we'll revisit all of these and more in the hands-on exercise which is coming up later in this section.